Hello guys, welcome to Coding. In this video, we are going to see the Leetcode problem number 295, find medium from data stream. Let's get into the problem. So the problem statement is the median is the middle value in an ordered integer list. If the size of the list is even, there is no middle value, and the median is the mean of two middle values. So if given the ordered integer list, the median is nothing but the middle value. But in case of even length list, the median will be the sum of two middle values. So yeah, I'll discuss about this later. So for example, the array consists of three elements, and the median will be, since there is only two possible ways for array to have the length. One is odd and even length. For odd length, the middle value will be the median. So in this case, 3 is the median. So yeah, 3 is the median. So in case of even length array, the median is nothing but sum of two middle values. So 2 and 3 by 2 will be 2.5. So median is 2.5. So we need to implement the class median finder, in which there is a constructor median finder which will be initializing the median finder object. So that's a function add num, which gets number integer num as parameters, and this function adds the integer num from data stream to data structure, and find median will return the median of every element so far. So answers with within 10 to the power minus 5 of the actual answer will be accepted. So yeah, we'll get on to the problem definition. So we'll go to paint. So before solving any problem, we need to define the problem clearly. So first step of solving any problem is to define problem clearly. You should not leave any point from problem definition. So the problem statement is, you need to find median. You'll be having a constructor. So it's a median finder. Let's call this as MF. So there is a function MF add, which gets integer as parameter. And finally, the third function is find median. So in these functions, what we need to return. So these are the input. So the input will be nothing but call to these functions. So there are two functions, namely 1, 2, and 3. So and in the first function, we need to initialize the object which we are going to store this kind of information, and add function will add the number to our list. So initially the list will be empty. So while we get the add function, we'll add the given number into our list. For example, if we get parameters add of 1, we'll add 1 to the list. So again we'll get the, when we get the function as add to, we'll add 2 to the list. So this keeps on going. So this is the operation to be done when add function is called. And median function is nothing but to find the median. So median value of the formed list. So when this is the list, we need to find the median of the list. These are the three functions, and the inputs given are ranging between 0 to minus 10 to the power 5 to plus 20 to the power 5. So yeah, that's the range. And what happens if the list is empty? So in this case, they have said that, wait a second. So yeah, when the list is empty, will there be any calls? So there will be at least one element. So they have mentioned that corner case here. So there will be at least one element before we call the find median function. So we don't need to care about the array size as empty. So that's all. We have successfully defined the problem, and yeah, we'll move to next step. So Yeah, I think you will be getting a clear idea of how to find the median. So now we'll move on to approach. So how can you approach this problem? So the first approach that comes to everyone's mind is to create a list. So we'll create a new linked list and keep on adding elements to the list when the add function is called. So we'll be adding elements to the list one by one. And we get the find median function. So we add the integer into the list on the sorted order. So each time we'll be adding the number in a sorted order, which will be taking a time complexity of O of n, and we'll for finding the median we need to use the formula, a simple formula, that is if the length is odd, we'll return the when the length is consider the length as n. When the length is odd, we'll return the, let's have the linked list reference as LL. So we'll return the L by 2, n by 2. We'll be returning this, and the length is, that is n is even. We'll find the median. So there will be two median, right? So yeah, we consider this case 1, 2, 3, and 4. The elements are 0, 1, 2, and 3. So the length is 4. So 4 by 2 and 4 by 2 minus 1. This will correspondingly get us to the second index and first index. So n by 2, list of n by 2 plus list of n by 2 minus 1 by 2, we'll have this in an array value. So the element that this will be the answer. So this will be the median in case of even length. So this is the first approach. The time complexity of the approach is the O of n square. For adding, sorry, for adding it takes a n, but for each time we add, so let's consider for one operation there will be n iteration, and for let's consider we have m number of calls to add function, so n into m. Let's consider n as n equal to m. In that case, it becomes n square. So when we discuss about the space complexity is p of n, since we use only one list. So this is the first approach. Can we find any better approach than this? And the answer is yes. So how can we do it? So consider the given test case. So 1, 2, and 3. So the elements should be in sorted order, right? So let's consider 1, 3, 7, 9, 10, 12. So we need the median. For each time we need the median. So this will be the average of this will be the median, right? So when we add one more element, 13, the median will be turned to 9. So how can we find the median in a better efficient way than the previous approach? So in order to find the order, so maintain the sorted order, we can have two priority queues. So initially when we get the first element, so initially there will be only one call to add, right? So when we get one element, we add to the priority queue, and in order to find the median, it's nothing but when the, so let's call this as let's store this in an ascending order, and this is in a descending order. So what I'm trying to say is we'll create two priority queues. So why are we creating priority queue? It's nothing but in order to store the values in sorted order. So firstly we need to find we keep track of the first previous elements and the next elements. So we'll divide the array into two parts, and the first part will be stored in the first priority queue and second part will be stored in the second priority queue. So why are we storing that? And actually in our we'll store this in first priority queue. Let's call this as pq1. So we'll be storing this in a descending order, and pq1, pq2 will be storing in a ascending order. So why are we doing this? So when we consider the elements 1, 3, 7 inserted here, and 9, 10, 12 inserted here. So in this case, when we need to find the median value, what we'll do? We'll just pick the peak value of this and peak value of this priority queue, both the priority queue, and add up and divide by 2. This is in case of even length. When there is odd length, so when we consider we are inserted element 17, so we'll be adding 17 to here. So there are 4 elements in the priority queue too. So in this case, we'll just return the peak element of second priority queue. So yeah, this is the usage of priority queue here. So we are storing the ascending order of the elements. So this is the pattern, new pattern that we have discovered. So while we are inserting an element, we need to check with the previous priority queue, and if the priority queue peak, first priority queue peak is greater than the inserted going to be element that is going to be inserted, we'll pop that and store this to 17 to first priority queue, and this element to here second priority queue. So yeah, you'll be actually I think you'll be able to get some idea. So you'll be very clear in the coding session, and the time complexity that it takes will be, we go off for each time we take a insertion time complexity of log n. So for adding element it takes log n, and for finding the median we take only we go of 1, so constant, and the space complexity is we go of n. So yeah, we have made the algorithm faster. So we'll get on to the coding session. There you'll get the clear idea of how we are doing the finding the median for each time. So yeah, in the firstly we'll declare the two priority queue, pq1 and pq2. So let call this as first part, first part of the array, and the second part. So first part will initialize the priority queue of reverse order. So initial collections dot reverse order is a comparator. So in basically the priority queue, every priority queue's default order is ascending order. So when we use this collection dot reverse order, this is the comparator. So this will be passed to the priority queue's constructor, and reverse order will help us to maintain the elements in a reverse order. So that is descending order. So second part is a new priority queue. Yeah, it maintains an ascending order. So yeah, we'll discuss the approach in detail. So we'll have two priority queues, right? So when we have initially element as 1, so where we'll be adding it to. So we'll add it to second priority queue directly. So this is pq1 and this is pq2. When we get next element, we'll check the size of priority queue 1 and priority queue 2. So this size difference can be 1, and the size greater the greater element greater size can be maintained in the priority queue 2. So when we get the second element, we have possibilities of inserting this element in two locations. Here first priority queue and second priority queue, right? But we are going to insert in the second priority queue. So why are you inserting the priority queue in second priority queue? This is because we'll for each time we'll be dividing the array into two parts, right? The first part will be stored in first array, first priority queue, and second part in second priority queue. So how can we store in that manner? So when we get the element as 2, so yeah, First initially we added 2, right? 1, right? So after now we'll get the 2 element as 2. So in the time we'll check whether the size of size difference is we'll check the size difference, and we'll add up the element to second priority queue. So 1 and 2. Now this priority queue has elements 1 and 2. So now we'll check the size. So size of first priority queue is 0 and second is 2. So 2 minus 0 is greater than 1. So we have crossed the difference. So what we need to do is poll the descending or descending, I mean the root value of the priority queue. So we'll poll the element and add it to the first priority queue. So now we can clearly see that we have splitted the array properly. That is first element 1 into first priority queue, 2 in second priority queue. Now let's consider we have an element as 3. So we are going to add the element 3. So how can we do it? Initially we'll have two variables as left and right. Since priority queue 1 is not empty, we get the peak value of priority queue 1 and peak value of priority queue 2. So that's 1 and 2. So we have element as 3. So we have possibilities of inserting element 2 here, this priority queue, or previous priority queue, first priority queue. So where we need to insert? So we can clearly see that we need to insert the element into second priority queue. So how can we be sure of that? So we'll take the left value and compare with the current value. We can clearly see that 3 is greater than left value, so we'll add it to the second priority queue. And finally we'll check the size values. Yeah, so this is the process. Now we'll insert element as 9. So where we need to add the 9. So initially we get the left value and right value, left and right. So left value will be 1 and right value will be 2. So we'll check the number 9 with previous left, and left is smaller than current value, so we'll be adding it into priority queue 2. And we can see the size difference is 1 3, so difference will be 2. So in order to maintain the balance, we'll pull the max, I mean the peak value from the priority queue 2 and add it to the priority queue 1. So this is the elements that is maintained. So 3 9 and 1 2. So this keeps on going. Yeah, finally we can conclude that the first approach is going to take the left and right value, and the second step is to find to after adding, so left and right and adding, and third is to check balance and maintain it, and maintain the balance. So these are the three steps that we are going to follow in this problem. So let's move on to coding session, so that we will get the clear idea of what we are going to do. So we'll have int ls if first part is not empty. Essentially, if first part is empty, answer this case. If first part is empty, we'll add the element to second priority queue. So second part that add num and we'll return. So or else we'll take the left value. Left value is nothing but first part dot peak value, and right is nothing but second part dot peak value. So what we'll do is we'll check the left value with the insert a num. So when L is greater than num, what we will do is we'll remove the first part's value. So first part dot remove. So this function will help us to remove the left value from the first priority queue and we'll add the current number to first priority queue. So after this, we'll add the second part, add the left L to second part. So we have removed the element, first part element, right, which is L. So we'll be adding it to second part. If L is less than or equal to num, what we'll do is we'll just add it to second part. So yeah, we have covered the first step. The first step is nothing but to find left and right, L and R. Second step is to add the number, and the third step is to balance. So how can we balance? So if second priority queue size, so we'll have our two variables as in size one as first part dot size, in size 2 as second part dot size. So if size 2 minus size 1 is greater than 1, we are missing the balance. So what we'll do is we'll just add the, we'll remove the element. So let's have element as CLE. We'll remove the element from second part. So remove and add it to first part. So first part dot add. So yeah, we have successfully completed the add num function. And for median, what we'll do is if first part is empty, we just return the second part's peak value. Or else what we'll do is we'll check the size. So if first part dot size plus second part dot size mod 2 is equal to 0, in this case we can clearly see that the array size is odd. In that case we'll return the second part's peak value, or else we'll return the median of left and right. So let's have double as ls first part dot peak and double r as second part dot peak. So we'll return the l plus r by 2. So we can reduce this and make it efficient by just checking the second priority queue. We don't need first priority queue. So let's check this out. We have got wrong answer. So what is this? So yeah, there's a problem in this. So we'll what problem we have occurred is it has made integer division. So integer division will only return the integer value and it will skip the floating value. So floating point will be skipped. So we'll convert the value into double and then we'll return. So let's check this out. Again we're getting wrong. So first part dot peak. So what mistake are we doing? So we'll try to convert this to double. So we'll print and see the priority queues. both the priority groups for each time a median call is called. So initially we had one two. In that case, we have returned 1, so this should be 1.5. So how can we make this make up with this? So yeah, we have imbalance condition here. So size 2 and size 1 is greater here. We can clearly see that. So we need to avoid this condition. So since we use this condition every time, the size will be in 0. So we'll remove this and we'll just get on to finding left and right. If first part is not empty, we'll get on to finding L and R. So first step, this is the first step. So if first part is empty, not empty, we'll take the left and right value and add the process. We'll follow this. Or else, if the first part is empty, we just add to second part. So let's check this out. That's working fine, and there is no issue with here. So it will work fine. Let's check it again. So let's submit it up. We are getting wrong answer. So in this case, so we'll print this first part and second part. So I will take the failed test case. And check this. Yeah, firstly I have maintained this properly. So -3 and -4. So we got -2 in the 1, 2, 3, fourth call. So we are getting a problem in the fourth call. So in fourth call, what we'll do is get the peak element of the first part and second part, right? So -4 and -2. So answer will be 1. So what is happening here? In the third call and the fourth call, the second part size is, sorry, I have missed a condition. The second part is not equal to 0. We'll return this. So we're working fine, I guess. So yeah, what mistake have we done? So In the second call, we have a wrong value. So we are getting as -1 instead of -1.5. So why are we getting that? So median should be -2 plus -1 by 2. So we'll try to convert here double values. Let's check this up. Um, we'll print and see this. We'll check this again. So -2 minus, yeah, we have formed the array properly, but what is the mistake here? So in the second call, we have -1 as the answer. So the answer should be, so yeah, this is right. In the fourth call, we are getting the error. So what is the fourth call? In the fourth call, -4, sorry, -3 and -2 need to be summed up. So -4 plus -2 will be, sorry, -3 plus -2 will be -5 and divided by 2 will be 2.58. So what we are getting in this? So if first for dot size and second dot size, so we check it up. It's not equal to 0. We'll return this again just. Yeah, this is the mistake we have done. So let's check with the sample test case. Now let's submit it up. So before submitting, we'll remove this printing part. Submit it up. Yeah, accepted. And that's all about this problem. So as we mentioned, the time complexity and space complexity are same like add num will have time complexity of big of log n and find median will have time complexity of big of 1. So that's all about this problem, guys. And approach for this problem is using of priority queue. And that's all about this problem. Thanks for watching this. Have a great time.